Alright, water can also cause soil erosion in a three-step process. So first is the step of detachment. That is where the soil particles are detached from the larger soil mass. Then we have transportation, where that detached particle travels downhill in the water. And then deposition, where that transported particle moves to a lower elevation and then settles out of the water. And so a picture of that would be detachment from rainwater splash here, and then that rainwater transports it down the slope. Then once the slope levels out or the speed of the water slows, that soil particle is allowed to settle out. And like I said, we use raindrops, detach the soil, destroys that granulation or our good soil aggregation that helps hold the soil particles together, and then that splash transports the soil, not only causing erosion, but soil splash can also cause some fungal or bacterial diseases in plants, especially agricultural plants or annual growth. Uh, Water and rain initiate most soil erosion, so this is why soil protection is a key in preventing soil erosion. Agricultural methods of managing erosion. So there's been several that have been developed: contour cultivation, strip cropping, terraces, and conservation tillage. So contour strip cropping is where we make sure that our rows are going across the contour rather than up and down. And then this process or this system down here has three different crops so that there is always something on the land. The harvest will be staggered. And then as well as the hay mixed in there. So we have a larger root mass that is better established rather than just an annual crop of corn or oats. And by staggering these, we can slow the water even more, preventing more erosion. Terracing, so this works well in very steep areas, and this is a coffee farm over here. This might be rice in Asia. And by terracing, we're able to stop the water at each terrace and force it back into the ground. So we increase the soil absorption while decreasing the amount of runoff. Conservation tillage practices, whether it's low till or no till, these have been more applicable due to modern herbicides and improved equipment that can plant and cut through the plant material that's left on site. And the benefits, we usually see equal or even higher crop yields with fewer inputs. At times you may see a lower crop yield, but you have to remember that you have lower inputs, and so the sort of net profit of the farm is often still increased. Conservation tillage leaves organic matter on site, requires fewer passes with equipment, so less costs of maintaining the equipment, decreased costs in running the equipment. And examples of this would be chisel plowing, stubble mulching, or ridge tilling, and then also no-till. So conservation tillage, here on the front, there's a roller crimper that is just matting down the cover crop, and then right behind it is the seed drill that is able to plant right through that material. And so the roller crimper sort of terminates that cover crop and then protects that cover crop, stays on the soil to protect the soil from raindrop compaction and erosion, but also all that good organic matter full of nutrients that will cycle back around for the new crop that is being planted. Impact of no-till or low-till practices. So we increase macropores and aggregation, which serves to improve our infiltration, our drainage, our AWHC, which is available water holding capacity. Are there any negatives? There might possibly increase nitrogen leaching. This can especially be true when switching systems, and so that nitrogen content was probably artificially inflated due to the previous practices, but eventually that will reach an equilibrium. And we have cooler, moister soils, which may decrease yield in cold climates. At times where we're pushing the soil to warm up in spring so that we can get our crop growing and have a longer growing season. But knowing your crop genetics can also sort of offset that. We have an increase in SOM, which is our soil organic matter, and which may immobilize nitrogen and other nutrients, um, as we have a surface accumulation of nutrients and an acidification of surface soils. So the greatest changes occur to the soil biology. We have an increased cover, which provides a mix of LOC, which is labile organic carbon, and humus. Is that most beneficial to bacteria or fungi? And we'll talk more about this when we get into the different kinds of organic matter and how they impact their microbes. But this system favors fungi. So vegetation control is another method to reduce erosion. This can be used more on the urban landscape. So narrow rows of permanent vegetation on contour that work much the same as the row cropping. So we slow our runoff, trap the sediment, and sort of can build natural terraces. Usually we use deep-rooted grasses, possibly trees, long-term perennials with deep root systems that can hold the soil in place. And so this is what it might look like in practice. Up here on the left, we have a hand-dug swale, which encourages the water to infiltrate as it's coming down the slope. And then the bottom right, a similar practice but using different levels of vegetation to encourage infiltration. So gully control. Gullies rarely form where we seed dense vegetation and often form when the soil is exposed, and they will continue to grow if left unchecked. And so what is a gully? So this is a gully that you may have seen somewhere in a wooded area that's been harvested, or agricultural areas with cattle often in streams. You'll see them around. And so this gully will just continue to grow and grow further back up the slope if left unchecked. Remediation involves slowing down the water, so we do it with grasses or dams or other diversion steps. And then worst case scenarios on steep slopes, we can have landslides if we don't provide any remediation efforts. So gully control on construction sites might be as simple as riprap piles here to help slow the water. This would be an agricultural site where there's heavier-duty dams built up to slow that water and trap the sedimentation. On rangelands, proper grazing and fire control, so not allowing overgrazing to keep a lot of that herbaceous material on site and slowing the water. Human predators, so humans moving cattle around to ensure that they don't overgraze. And then preventing cattle and anthropogenic or human-caused trails. In forest operations, so logging operations and roads, there's a guide out by the U.S. Forest Service that regulates these operations and road buildings. Recreation, so trails, whether ATV trails or foot trails. And then I mentioned the tragedy of the commons, so someone thinking, oh well, if I go off the trail, it's not that big of a deal. But if everyone thinks that, then everyone just went off the trail. So forests, the best practice is to limit soil surface disturbance. So having a variable natural forest floor. Timber harvest, so intensity, timing, location, and the harvest systems can greatly alter or have an impact on the extent of water erosion. Some of you may have seen one of these. It's a forest water bar, so it's directing water across the path rather than down it. See them often in state and federal parks on walking trails. So this is an effort to prevent all the rainwater from rushing down the trail and just divert it in a different direction. Construction control can result in, so construction can cause over 100 times the erosion as agriculture. We need detailed control plans, thank you to the Clean Water Act, to avoid on-site damage and retain eroded sediment on-site. So this is an example where the construction control failed, and we see all of this water and sediment rushing out. And so in some areas a triple barrier might be required. This is a silt fence. Sometimes it's as simple as hay bales that are staked in the ground. But something needs to be there to disrupt the water and encourage sedimentation. 5 basic steps would be scheduling during low rainfall periods when possible, have as many phases so that the whole area isn't disturbed, but if we can disturb, a corridor at a time, that will help prevent erosion during rainfall events. Covering the disturbed soils, not just piling it up and letting it erode, but maybe pile it up, cover it with a tarp. If it's long term, you can cover it with annual grass or something like that. Controlling the runoff from the site, and then trapping sediment. Those often occur simultaneously. Runoff control could be mulching or hydroseeding. We saw riprap earlier on the hillside, laying contour strips of sod. Even if you are seeding, that sod is an immediate barrier to water movement, and then holding ponds where needed. So mulching, here we have just seeding and mulching to encourage grass growth, but then also these large tubes to physically prevent water movement and trap sediment. Hydroseeding provides a mulch and a seed right away to help cover bare soil. Riprap installments, whether that's large and sort of just dumped and alongside a road, or this here is a little bit neater, kind of filled in around it, but still works to sort of disrupt that water flow and help trap the sediment. Like I said, sod on the contour is a great way to help trap water while we wait for grass seed to grow in. Sod has a higher cost, but also a higher benefit when used in this way. And then construction control, so this is a retention pond these are often required during large developments now to help hold some of that rainwater, get the sediment to settle out, and then discharge out